Good morning. Today we're going to talk about ionic bonds. Sorry, I'm a little sick today. I sound awful, but put it on mute if you can't take it. So we're going to do Lewis dot diagrams like we talked about yesterday, and we're also going to use how you formed the charges on that to tell what compound you made in here. So in ionic bonds, we're going to be using the electrons just like I showed you on that diagram yesterday. I'm putting a blank copy of these notes on Canvas. If you want to print them out first and copy these down, you can. If you just want to watch, that's fine too. Just make sure you're understanding what we're doing. So what we're going to be moving is we're going to be taking an electron. I'm just going to put E minus for short for the first element, and that's the metal. So remember, metals are in the left side of the table except for hydrogen. So we're looking for things like lithium, sodium, calcium, potassium, things like that have very few electrons. If you have very few electrons, you'd rather give them away. So think of it like tickets to ride something at like a fair or something like that. If you just have a couple tickets, it's going to be really hard to find enough people to go in something. But if you're almost full, you have like 6 or 7 and you need 8, you probably can find some people with extra tickets to go. So it's just like having more than you need of something. So things that have multiple levels on that, it's like they have extras on there. And it's easier to get something, just give something away and go back down in energy level than it is to fill something that's less than halfway full. So then you're going to give that to the non-metal. So remember, non-metals are things on the right, the gases. So usually when we're doing these, those are in the second and the third columns from the end. The noble gases don't like to bond, but that -1, the -2, and that -3 column over there. An atom can gain or lose more than one. So sometimes you're going to be moving 2 or 3 electrons on there. So some of them are going to be really easy. Other ones are going to take a little bit more work, but at the end you want the perfect situation for both atoms, that they have a full outer shell, which for most things is 8. If it doesn't even out right away, you're going to have to draw multiple atoms. So if you have 3 to give away and the other one can only take 1, you're going to have to add 2 more atoms to get rid of the other 2. Or if one has 2, one has 3, that's going to be the longest situation. So sometimes you might even have to draw up to 5 atoms. Okay, so let's do a fairly easy example in here. Calcium combines with chlorine. So calcium, when you look in the periodic table, it's in the second column, so that's the number of valence electrons. Chlorine is 1 away from being full, so it has 7. So we're going to draw the Lewis dot structure for each of these. So calcium, I'm going to draw with 2. Chlorine, I'm going to draw with 7. It's a halogen, 1 away from being full. Now we look at this and we want to think about what's the metal and the non-metal. And I'll give you a hint. Usually they give you the metal first and the non-metal second. There might be a problem or two that don't, but usually that's the way we go. So you need to decide who's going to want to give electrons to who. Calcium has 2. Those are 2 extra. It's not very many. You want 8. Chlorine is so close. So calcium wants to give its electrons to chlorine. So I'm going to take this electron here and I'm going to move it here. You do not have to redraw this on here. You can just put the arrow and we know that that's just moving that there, so you don't have to show it. But in actuality, that electron would be over there. But we have a problem now, and calcium still has an extra electron. So chlorine's great now, it doesn't care. But we need another calcium, we need another chlorine to get that calcium's other electrons. So now we're going to grab that other electron here, and we're going to fill it in here. And remember, when you're drawing your pictures, you want to spread out those electrons. They are single before they double up on there. So I saw some of you trying to put them both on the same side. We like to spread them out on here. So now we finished our picture. Everything's where it wants to be. So the last thing we're going to do is we're going to show a formula in here that says what happened. So the first thing you do is you write how many of each ion you use. So calcium was 1. And in chemistry, we don't write 1 as subscripts. If we don't see a number, we know it's 1. But there are 2 chlorines. So since I had a chlorine here and a chlorine here, that's why I put the 2 there. Okay, but calcium was just 1 on here, so we don't need a subscript. The last thing we need to do is we need to add charges to this. So we're going to look and see how many electrons it lost or gained. Now we got to be careful. The metals lose and they have a positive charge. So your first element should always be positive. Your nonmetals gain, and so they're going to be negative on there. And if you had more than one, like we did in calcium here, we're going to tell people that. So in calcium, we have 2 electrons, so right here and right here, and they were given away. So remember, like that balloon in the sweater, if you give something away, you're positive. So we're going to write 2 plus. And then each chlorine here got the 1 new electron, so where I circled the arrows here. So they're just going to get a minus on here, which means they gain 1. So it is not the same to write 2 minus. 2 minus would mean that both electrons come to the same atom. Here, this tells us that calcium lost 2. Chlorine, there are 2 of these, which each gained 1. So make sure your formula at the end says what you're trying to do here. All right, so again, when you write the formula in here, you count the number of positive metal symbols you used. You write that number as a subscript and do the same thing on there. You write that as an exponent, so a pi. Gained is going to be negative, and lost is going to be positive. And if you gain or lost more than 1, you're going to add that number as a charge. So lost 2 would be 2 plus. Gain 3 would be 3 minus. So again, you're just summarizing at the end what happened on here. All right, so let's look at another one on here. So magnesium has 2. Oxygen has 6. So let's draw Mg with 2. And again, this is just drawing the outer valence electrons, not the whole Bohr model. Okay, so again on here, since I had 6, I put 1 on each side and then I doubled up on 2. It doesn't matter which 2. So when I do this on here, magnesium has 2 valence electrons on there. It doesn't want them. O needs those. So this is the perfect situation. We're going to move those over. So magnesium gives 1. It still has another one and O wants it. So we're done. That's all we have to do. So for the formula, we use 1 Mg. And each one lost 2. We use 1 O, and each one gained 2. So our formula here, first we write how many Mg's and how many O's, and if there's just one, we don't write any subscript. So that's what happened here. Mg gets 2 plus, and O gets 2 minus. Okay, here's another one where you need to do more than one. So Na is 1, S is 6. So draw Na with your 1 electron, draw S with 6, and again, make sure each side has one before you double up. Okay, so in here then, Na, there was not enough to fill up sulfur, so I'm going to need another Na, and it still has 1 electron like all of them do. And we push that over. So when we write our formula, we use 2 Na. Each one lost 1, and we use 1 sulfur, and it gained 2. So the first thing I'm going to write is how many Na's and how many S's I use. So there are 2 sodiums and 1 sulfur. So my first part of my formula is Na2S. Each sodium gave away 1. So again, I don't want to say 2 plus because sodium doesn't even have 2 valence electrons. And then sulfur gained 2 from on the same sulfur atom, so Na2 with a plus, S with 2 minus. All right, so why don't you go ahead and try these on your own. So why don't you get out a piece of paper now and go ahead and try this and pause the video. And then I want you to do this. So look where Al is. Al, we skipped the middle, remember, so we count on the left 1, 2, and then Al is in that first column with 3. And then bromine is in the halogen column, so it should have 7. Okay, so we're going to draw Al with 3. We're going to draw bromine with 7. Al is the metal, so it gives. Bromine is very close to being full, so it accepts. Bromine's great, but Al is not happy yet, so we're going to draw another bromine. Move this one over. Again, this BR is 7, so just leave one side open, doesn't matter which one. All right, they're now both where they want to be on here. So write what you use, 1 AL, 3 BRs. AL lost 3, so 3 plus. Each BR gain 1, so it gets a minus. And again, it's fine on a charge to have a 1 there. Most people don't write it, but I wouldn't count it wrong if you had it. However, we don't want to see 1s as subscripts on here. Okay, so it likes to make this. So we'll learn soon that this will be called aluminum bromide on here. And it's the only way AL and BR will want to match up for that they both get the electrons they want. All right, last one. It's the same thing. Let's try the 12. Ca with P. This is the worst you're going to get. When you have one that's either a 2 plus and a 3 minus or a 3 plus and a 2 minus, you're going to have to add a lot of atoms. So go ahead and try this one and then check your answer. Calcium has 2. Phosphorus has 5. So calcium's a metal, so let's give those electrons away. Okay, so calcium lost it. It's where it wants to be, but look, phosphorus only has 7. Now, unfortunately, calcium can only come with 2. So now phosphorus is full, but there's still 1 left in calcium. So you always want to add the other thing. If you have ones to give away, then you're going to need to add the other element to take them. Okay, so phosphorus is a little bit more full. Calcium is where it wants to be, but unfortunately, this isn't full yet. All right, so we finally got this one filled in on here. So we're going to write what we have. Calcium, there are 3 here. Phosphorus, so again, that's because I used 1, 2, 3. And then phosphorus, there were 2 of them. So that's where I got the Ca3. And then P, there's 2, so I'm going to put the 2 there. Now I have to say what each one of these did here. So each of the calciums gave up its 2 electrons here. So that means on our charge, we're going to write 2 plus, because remember, if you give them away, you're losing them. Now for phosphorus, each of the phosphorus gained 3 new electrons. And remember, when you gain, that's negative. So Ca2 with a subscript 3, P with a 2, and subscript 3 minus. And you're going to notice some patterns on here when you look at some of these things. Notice that we see the 2's lining up and the 3's coming up. So a lot of times those numbers will be there. They won't always. Sometimes we'll see them cancel out. All right, so to wrap up, I want you to practice this on the other paper, and that's what you need to submit to Canvas. I don't need your notes. If you copied them down, I think it's great if you did that, but if you didn't, that's fine for today. All right, email me if you have any questions. Hope you have a great day, and we'll do a little more ionic practice this week, and then we're going to switch over to covalent.